So I'm here to present the work. I'm not part of the main team, so AutoGen is a set of components principally developed by Microsoft Research. Victor and Chi were are the main author in there. I contribute to them and I work with them. I belong more to the enterprise stuff. So I'm part of the Microsoft Corporation more than Microsoft Research. So what we're going to see today is that we're going to talk about multi-agents and think about, what is all about when we're thinking about AI. We're thinking about AI where agents can take things further for us, and we would like to get through into asking a complex task. We're asking to write me a novel, or in a less open-ended creating things, you might gonna ask question about changing your workflow strategy. Like this point, it's like, is it possible for a roastery 1 to be only used by Cafe 2? How would that affect our performance and cost? Or in theory, we will get to the point where you can have a conversation and go through something as complex as building a big chunk of software. That means, let's build a mobile app for Android or whatever you're gonna need to do. A complex task is defined as something that requires some form of planning. And so it needs to be something that AI needs to be able to decompose into steps. He cannot be done by a single person. That's why usually when we tackle complex tasks, we have a team, and in the team, you're trying to go for hiring diverse expertise, backgrounds, perspective, and so on. This means that there is some form of specialized knowledge that gets into the soup for cooking the app and the problem. And also, the process might require for the system to gather additional information, which could come in any sorts of form. It could be things that you're getting from large amount of data, as in query things, structured data, PDFs, web scraping, and all those things. The problem is that as you do these things, and we all know that as you're going through a complex task and a plan, the first thing you evaluate is, am I on the right track? So the plan itself might need adjusting because of any sorts of environment changes. Timelines, the sources you thought you had available are no longer available, the target moves, and so on. So planning in January and stick to that till the way to December is not usually something that we as thinking people will describe as insanely clever and safe to do if you are in an environment that shifts monthly, if it's not even weekly or daily basis. So that's what usually complex tasks are. And for example, if you look at this one, this is like a little bit of workflow of what's going to happen if we were to ask the question, to solve the question about what happens to our cost if we change the way we use some resources. In this case, it's the coffee from Roastery 1 only to be used on Cafe 2. You can see that there are a few reasoning steps that they go into solving this problem and trying to find an answer to this question. The first thing that you go in, of course, is trying to read some document, some content. Once you have the content, which usually is unstructured things, you have the other problem where some of your data is, of course, stored into some reporting or your system where you've got operational databases. That's where the real thing is. The operational data lives. So now we need to get it, but you need to get the one that you need. At this point, we're all concerned about you give these things and you get an answer back. When somebody's giving you a report, I hope that you accept that information in a very critical way, in the sense that, thank you for your job. How did you get to this conclusion? That's what I would describe as a solid way to accept information. So get that blindly, it's a problem. So at this point, do we have a human in the loop? Maybe yes, or we got other system to judge on that. Finally, if we are all okay with the document being gathered, the assumption that the system is doing, it can come back to you and give you the beautiful PDF or even the PowerPoint to go off and do your presentation. So you can see how all these dots things is where communication happens between parties, there are some reasoning steps, and you can see that there is also an action that needs to be taken into account. Now, even more interesting becomes if we think about build me an Android app. I think we all agree that the one-man band or one-woman band doesn't work when you're trying to do an application unless you are beyond the full-stack developer, which means you're able to do quite a few things. Gathering requirement. You come up with a UX design. This thing is a mobile app. Somebody's going to get in there and decide how this thing is going to interact with the user. Then you finally start doing some of the code. That's your client code. Now, if you're doing the client code, very likely, if this thing is useful, and depending on your business model, that's going to be some backend. Now we need the backend too. And I hope that you get tests for your software and that the tests are passing. So at this point, you can see that just going through blindly doesn't work. You know, the one prompt, if that was working, you can just go home, open your chat, whatever, Bing chat, and just ask it, make me application that makes money. I tried. I still have to do my 9-to-5 job. So I'm waiting for that moment. So there is one other step that I, as an enterprise person, I try to bring to the picture. How do you go through thinking of that? Usually it's what I like to go through more than test-driven or behavior-driven design. I like to tap into domain-driven design. The domain-driven design is when you talk about what you're trying to do in the same term that the business uses to describe the process. So usually what you're going through is about, you're not going to talk about a server, a backend, or a database when you're doing DDD. You're talking about your account management, the customer, the basket, the inventory, the supply chain, the billing, the shipping. Those are the terms that you use. And so when you start thinking about that, you are essentially defining names of things, of actors, and you are introducing dependencies as resources that your system need, but also the action they're going to be performed. So at this point, you're describing more or less in natural language, but your language shrinks down to the vocabulary that your business is using to describe how they operate, how profit, hopefully, is made in whatever that you people do. For example, if I were to think of, if I'm trying to build a system for a travel agency, if I were to go down a more DDD, so domain-driven design approach, as opposed to starting to think about servers, databases, sharding, cloud resiliency, and all those things, that's how I would think. You go in a shop, there's going to be people in there that you interact to get your thing done, which usually is to try to find if they can sell you a package that you like. That means it's going to be some people in front of you, the front office. Who is at the front office? Customer support, product specialist, and travel expert. Then you're going to have back office. Somebody on the back will take the information that the front office is gathering and is going to go off, find you what kind of tickets are available, what will be the cost, times and things, and so on. And then the resources that all these people use are the systems and functionalities inside this company. So that would be somebody's using a terminal to find the most convenient flights and then hopefully book them and then bill you to send you email, find accommodation, all those kind of things. So if I were to think in a DDD approach of this application, that's where I would start decomposing. So now, as you see here, I don't mention anything about if this thing is going with batch processing overnight kind of things, big data, Spark, Kafka queues. There's none of that. I'm not telling you if it's GPT 3.5, Turbo or not. I'm very just trying to talk business terms, but thinking that these business terms will turn into things that do stuff. What are these things? These are the agents. What are agents? Agents, generally speaking, are something very simple. It's a computational model that goes back in the 70s. It's a loop And inside the loop, an agent, the only thing it does is that it perceives the environment, plan, does some action, rinse and repeat. Every time an action is performed, the environment might change. That's when the plan might change. It does another action, and you keep on going. What we see in this beautiful era of LLMs is that we're trying to go into a much more specific kind of area. That's what they call the conversational agents. These are a type of agents that, more than perceiving the world, the perception of the world is what is told to them. So now these agents, they have that loop that we saw before, but the way that they work with each other is by talking to each other. So the environment that they share is the conversation that they're having. The output that they produce to each other is what they tell has been done. Internally, stuff happens. These kind of agents will do things inside. They could perform action, calling some server, turning on and off lights, whatever you want. The act can be much more complex, but the interface of this agent is pretty simple. I ask you something, and then this agent starts producing back answers. So the interface is seriously simplified as one, and you keep implementing the same over and over and over again. So that means also that composing them is trivial. That's the basic of the agents. But some of them will require additional things that they can do. You might require them if we think about the back office. Think about if you got the back office and the front office. If you are in the front office and you're meeting the customer, hopefully you've been trained into things like, oh, have you seen this customer before? Oh, yes, I did. Do you remember the preferences of this customer? Cool. Can you immediately start pointing onto a product that we sell? Again, the profit at the point is how much time you need to sell a product. That's giving you your rate of profit. So if you can learn from your customer and be faster and more precise with less resources, profit goes up. Some of them, and they can just talk to you. The people in the back office, they will need to be able to navigate the terminals and be able to press buttons to find flights and press other buttons to book them. So they need to have tools. Do they need to remember every single flight that they've booked for people? No. That you're not expecting your back office to be such interaction aware or understanding. Probably the back office doesn't work with customer management system, for example. So the customer relationship system is something that more likely is used by the business and the front office, not the back office. That means also that some of this information, you store it and you review it. So some of these components will need to persist and retrieve and progress the job. But then it comes at some point we invented these new people called the data scientists. These people, what do? They have an expertise. Their tool is a higher level. And some of these conversational agents are required to be able to adapt as they go. You might not have the system. When you don't have the application that you need to do the job in your business, what do? You go down into those dark rooms where they lock people like me. And now we start thinking that, oh, business needs a system to do X, Y, Z. I generate code. I give it that to you. And especially data scientists, they have this approach where the code is the tool that they use. So they immediately consume it. There is no shipping of a 2.0 system for pricing at that point. And so now if we start looking at the complexity of moving through, now that we have LLMs, LLMs are interesting. They can solve tasks, but what they can do is really the one-shot question. They have a knowledge that they have accumulated to their training. So when you go in with just LLMs, you can ask what is the capital of Japan or stuff like that. That we very likely answer unless the capital of Japan has been changed in the last 2 months. But you still got, the problem is they got tons of blind spot. It's a one shot. It gets in, gets your question, and the only thing that is being taught to do is answer back to you. Nobody told to the LLM, you need to answer consistently, and if you don't know the answer, do this other thing. It will answer you. Now the problem is that can go down through few things like performance, and by performance I mean the quality of the answer, not just how long it took, but also hallucination and so on. That's a problem. Now, you build an agent which, as we said, is able to reason and do few things and call things. Now, because it can call tool, it can reason by step because the agent has a loop. And you can see that there are quite few interesting techniques like React, which is reasoning and act prompting, where you are forcing the LLM to think one step at a time, decide what to do. You have this tool, pick one, do it. Have you got enough to complete the task? No. What's the next step? These are the two. Cool, keep on going. And then you can see that the problem could be now, hey, can you plot me the price changes of the last quarter for this stock? They can do that. But as the task progresses, we all work in teams for lots of reasons. Pair programming, all those kind of things are there for a reason. They increase productivity and quality. At this point, you're able to do something very, very different. Like if you were to build a house, would you hire one person and make sure that this one person had every single tool needed to do every single job, start to finish? Or maybe you build a team where everybody is specialized, very skilled in using a set of tools to get one job done properly, and all together, once they coordinate and hopefully deliver in time, you get the house done. That's where the multi-agent comes in. So at this point, you're thinking, if we roll back onto the old school, solid principle, and also the domain-driven design is about these context boundaries. Each agent performs a set of tasks that are well-defined, is not the one-man band. They don't go beyond the comfort zone because they ask other agents to do the job. That also means that you can introduce a little bit more interesting things. So at this point, the mobile application that you've seen, there were other agents. One is trying to come up with the requirement, make a UX. Once the UX is sort of defined, you ask another one to make the code. The other one is doing the backend, and another one is trying to validate that those things behave correctly. If the thing doesn't work, they feed into each other. That's where, as you can see, the user effort fades away, not completely, or it's up to you to decide how much control you give back as you move through this. So if you look at this is the problem of getting this plot of the stocks, and if you go just with the LLM, it's gonna just, hey, I don't know how to do that. This is the code. Awesome. You copy paste somewhere, you try to run it, it doesn't work. Oh, this is the other, try this other thing. So essentially you are part of the loop and you're really going, and until you are able to make it run completely, you're stuck. So it can adapt based on what feedback you give back, but that's also limited to the experience that you have in writing code, for example, in that domain. And you need to have all the tooling and know how to, run the Python, install packages, and so on. If you have a pipeline where the LLM is going through, now you have this self-refining tool, because now it's having tool to do a few things. At this point, you can have a tool that just fetches the stock values using Yahoo Finance. And then there is another tool that takes those things, hopefully makes a data frame that looks decent, and then once you have that, you call another tool that gives you back the plot. In this case, for me, business user, it's easy. But now you go into that dark room where the developers were, because you need to ask them to write this tool and integrate. When you move into the multi-agent, then there is a very low developer effort, but also a higher adaptation. Because at this point, the agents themselves, they start trying to write the code. I try to run it, doesn't work. What was the problem? The error was this one. How do you fix this error? Like this. Change the code. Rinse and repeat. very likely you get at the end this works. And actually there's quite a few demos that are quite interesting where with a system like AutoGen, you have two agents. One, it's you. You just ask it the question, it keeps going through, and all of a sudden it gets the code to work, and you get your plot for the stocks, and then you can ask it another question. Oh, I just want a baseline, and it's going to add that one. Oh, I want this other stock too. Oh, change it. I don't want to see quarterly. I want to see just price variation as percentage over the last year. It's pretty cool. It works. Why now multi-agent? Because we finally reached that moment in time where off the shelf, for a reasonable price, you get access to very complex LLMs. You got GP3 at this point, 4.0. So now we're talking multimodal. The problem has always been that if you don't provide the things as textual, but now you could provide them as part of your question, a PowerPoint. They can understand the plot. They can see a table. So now you're able to have much more complex and rich communication the way you would have with other intelligent being more than anything. And also, you reach the critical mass where it's easy enough to prototype things along with your business, see if it works, adapt, change. So there are a lot more things that you can unlock and tackle with AI and agents today. The other thing is that there is a lot, there's always been a lot of demand for automation. I spend quite a lot of time in finance, all the things, the automation, robotics, whatever. I don't know what you guys would call it these days, but those were the terms when I was young back in those days. So the dream of then using NLP, data scientists with deep learning model, all of those things that have always been there. Finally, there are flexible things with a lower effort of coding and less complexity from a software engineering point of view that can take you there. And then the other point is that because we're going with AI, and a lot of few things that happen is about building safeguarding system. Those are things that they review things. Is the content appropriate? And by appropriate, you got the ethical AI, but also the things about some of the information that I use for the internal computation must not be presented in the final results. For any sorts of reason, ethical, legal, regulatory, all these things are really lending themselves into building multi-agent. Now, building multi-agent from scratch is not exactly a 5-minute job. There are a few things that needs to be considered, and especially when you're trying to, how do I add the tool to the agents? How do I orchestrate the conversation? It's hard. Not as hard as it used to be, but I wouldn't call it, the task that you just give to a junior as, oh, in the first week, I just had you. Have a go, do stuff. But now you, in a sense, you can. AutoGen as a framework is really trying to focus on, as I said, collapse everything. The only interface, the only contract, the only programming model that you see are agents that talk to each other. How? It depends. One to each other, pretty simple conversation, you can see at the top. Or you can start building a lot of complex scenarios. Chat rooms, orchestrator that select who's the most appropriate one to talk right now, given where we are in the task, the other one that does the code, the one reviews, the other one codes tools, and so on and so on. You, the people, have been flattened in this architecture as an agent. That's what is called the user proxy. The agent sees you as they see each other. So they could send them a message, but the LLM, it's you. And that's when you can put yourself into the loop of, execute the code now, make that booking. No, that's not what I meant. Can you review then these things? At this point, as all interfaces are unified, in the API here, you only have a couple of workflows, and the three components are a chat manager, an assistant, and then the user proxy. That's all that there is into the programming model, and so you can go from things like this. You build the chat, and you initiate the chat by saying, hey, this is the question, and the sender is and you pick whoever is initiating the chat. And this is how you can see the workflow of trying to build the application. It's very simplified, but that's how it works. Pros of multi-agent, easy to maintain because, again, the interface is just only one. It's easy to make them collaborate with each other. It's all easy to an extent. They can also supervise each other, so you can build self-checking or metacognition systems. Also, you can tell that each agent can use different LLM. So it's not one size fits all. So now we are controlling the quality, the cost, the latency. Because the cons is that these systems tend to be quite intensive on LLMs. So latency and cost could go decently high. And that brings quite a few things as point of failure. That's why if you look for some of the results of the Gaia benchmarking is when there are 3 classes of problem where, of course, you go from this is just a question you should be able to answer just with the knowledge that you have to the level 3 where it needs reasoning and plan. And if you go there, are updating that, you can see that the rate of success, even with expensive and complex and powerful LLMs, drops significantly in being able to accomplish tasks of level 3, which usually those are the kind of things that you would like to see done for you. Given conversation, you can build any topology. And here, this is some few of examples, but the travel agency, that's how it looks like in AutoGen. And in that respect, I would like to play an awesome video. We're going to talk about that just on top. It's just 6 minutes. So the first part you've seen, I built an agent that learns from me, and is a very complex system that tells a joke about cats and ninjas. But you can see as I talk with that, he's trying to come up with jokes. And I asked him, do you know what I like? I told them in previous chat that I don't like racist jokes and stuff like that. So the thing has been persisted. He knows it's me. And so he's focusing on things as I like the jokes, what a developer's enter a bar, blah, blah, blah. And then you can see, some of them are interesting. I don't know why I picked. The other one is that I picked football. Thanks to the training things, he made the assumption that football meant American football, so I had to tell it, no, I'm in Europe. When I say football, please do understand what you think is soccer. And he did that. But he's not very good with things about kaijuns, and so those jokes were not really good, and so I asked him then to work on that and learn that I like jokes. There was one that was pretty good, but he keeps confusing King Kong with Godzilla, and King Kong doesn't qualify as kaijun, so not too good. So we leave that, and now we move. This is the actually code of the travel agency running. And what you're going to see that as we go through this is that the chat is initiated with making a trip. This thing is going to go faster because I forgot to clean the memory. The front office learns. So as soon as I tell them what I wanted to do, it keeps going, cool, I know you want to go to Tokyo, and these are the stuff that you want to do. And so as I say that what I want to do is going to be in this chat, it's going to immediately jump into few things. Now you can see by the name which agent is talking. The customer assistant now is the trip assistant immediately, and it's telling me, those are the things that you want to look out for if you go into Tokyo. And then it's telling me what I need to do. You can see that now it moves off. Now the thing that you see there, purple, is interesting. In this case, one agent is a little bit more clever than the other one. I'm using a React loop. When you see purple, is the agent thinking on itself, what should I do to answer this question? That's the one asking me to find location. Now we found some flights. The flights were found too. You can see those are awkward JSON things. That's what function call are performed. And you can see that the answer comes back to me in English. Hey, these are the options that I've got. Which one do you want? Now, it's going to realize that I'm a stingy person because I'm going to ask for cheap flights. And that's where the reasoning comes in. Then I tell you what accommodation I want. And then because I'm going with a friend of mine, and he likes to dress as Super Mario, so we asked if there was any activities he could do. And then I was asking it to send me the confirmation email. Now you see that it's cooking the email, it's fetching the data. That's the data being fetched, and then it's sending me the full confirmation. Hey, this is your package. All the tools, no real travel has been booked. It's this is all self-running, so if you run this at the end of the slides, but also if you go back on the Pydata conference, if you look at the session description, all the reference that I've been doing here, that are available to you, including the code. Then, of course, I asked to book tickets for the Ghibli studio, and unfortunately, it wasn't aware that Gundam Factory has been shut down. So I tried to book that too, but that's when the RAG system should have been contacted to realize that a few weeks ago they completely closed. They finished dismantling that, so there's no point of going to Osaka to see the Gundam. But it's also pointing some interesting things to do about ninjas. You can see into this video how these things is going back and forth, and again, blue and purple, that's an agent reasoning on itself and trying to use Wikipedia to supplement any information. Now that we've seen that, we can move to the end of this. AutoGen is open source, is Python, and there is also an implementation for .NET. A lot of things that you've seen are contributed by community. We got very interesting tooling, like additional type of LLMs, multimodal beyond GPT-4V and O. We also have integration with other systems. When it's persisting knowledge, underneath the hood is doing all the RAG thing for you using, by default, ChromaDB runs on your machine. You can plug it with whatever you're using, Quadrant, all those things. And so when it's accumulating knowledge, it does that. You can use Llama Index that's got and LangChain that have very sophisticated loop for reasoning chain of thought. So you can make one of the agent a little bit more deep in thoughts on how to solve a task. The other ones talk to each other, supervise, and calling tool. These are most of the open challenge, generally speaking, and that's about the managing of what we call it memory. Memories of many shape is your experience on how to solve a task. How did you achieve the result? Then there is the working memory. What knowledge have you used to accomplish that? What part of that knowledge was relevant to the task? So these are all interesting and important things to think through to make agent being able to focus, avoid hallucination, learn, be faster the next time they see a similar task. They have like a run book. Oh, I've done this before. Very likely, I should start by looking at these steps, and then I go, instead of starting every time from scratch. How do I book a travel? You know how to do that. You've done that, and so that's how we do it. And then, of course, responsible AI. That's seriously important because also there is an LLM call. In itself, it is already kind of a multi-agent system, and you need to think how responsible AI and ethical AI, safety and privacy concerns it's to come into place. And with that, I'll leave it here so you can join GitHub and Discord. And to you people.